this slide. This is the first slide from the Inconvenient Truth slideshow. I am part of the Climate Project, which is Al Gore's group that trained 1,000 people, actually now it's a little bit more than that, to go around the country and around the world giving the Inconvenient Truth talk. As part of that training, he explains how there's a certain hope budget, and you really should not get too dire because you'll turn everybody off if you do that. I was once giving a talk at Cornell, and they were filming it. You're not allowed to film the Inconvenient Truth talk because of copyright issues. So I decided to give a different talk where I didn't follow those rules. And it got a pretty good reaction. I think that people like to be told the truth, even if it's not very pretty. So instead of an inconvenient truth, sorry, I jumped ahead there. I'm going to go back. Instead of an inconvenient truth, we're going to talk about a really inconvenient truth. We're going to go beyond an inconvenient truth. By the way, show of hands, how many people have seen the movie An Inconvenient Truth? Or now just almost everybody, but not everyone. So the really inconvenient truth is that the recent information we've all been given about climate change, the main source of that being the UN Intergovernmental Panel on Climate Change, or IPCC. That information that came out in 2007, it's a report that says things are going to be really bad if we don't do something about climate change. So the really inconvenient truth is that that report is essentially a best case analysis. And the reason for that is that there's a lot of reasons. The information that's in that report had to be submitted years earlier before updated information was available. There's governments that are overseeing what the scientists can put in the report, and China doesn't want to see certain things there. And so there's sort of this consensus building thing. So everything in the report is pretty much assured going to happen. But there's a lot of things that are going to happen that aren't in the report. And so we're going to go beyond that. And instead of considering the best case possibility, we're going to take a look at what the more expected case is going to be. And one way to look at this is to take a sort of a probability curve, where on the higher it is, the more likely something is. And on the left side are better outcomes from climate change, and on the right side are the worst cases of climate change. So you put the IPCC, it's sort of on the left side. It sounds pretty bad when you read the report, but that's pretty much the best we can hope for. What's more likely is something that I'll call biblical, because it really would fit the description of what's in the Bible. And on the right side, with a unfortunately not a very tiny probability, with a reasonable probability, it could be game over. And game over means we're not here anymore. And we're going to see why that could happen. Well, one reason that the IPCC report is conservative, I call it, or sort of a best case scenario, is that it used linear models. Linear models are easier to formulate, they're easier to agree upon, which is very important in a consensus building thing. And so, and that's how it is. But the real world doesn't tend to work that way. The real world is discontinuous. And let's take a look at a very practical version of that. We all know what H2O is. It's water. Well, it's water when it's warmer than 32 degrees Fahrenheit. But when it's less than 32 degrees Fahrenheit, it's ice. And it doesn't like slowly transition from one to the other. It's either that or it's this. And this is actually a rather apt example too, because this is pretty important in terms of the ice in the Arctic and the Antarctic, because we're warming it up right now and it's crossing over 32 degrees. So, in fact, let's take a look at a chart from the IPCC where it's predicting how soon this summer ice in the Arctic is going to melt. So this is from the starting point. 100% means there would be no ice left in the Arctic. And they predicted that basically around 2080, about 2100, all the ice would melt. But in reality, the ice is melting very quickly. It's about half gone now, and it's going to be all gone in the next 5 or 10 years. And if you don't believe that, you could take a look at actual satellite images taken year to year in the summer of the Arctic ice, starting in about 1979, 1980. And it ends there in the middle. I think if you play that forward in your mind just a little bit, you'll see why it's such an amazing thing. This is, by the way, not very subtle. This is something you could observe from the moon if you were there. And the problem is that ice reflects about 80% of the sunlight hitting it, and dark water absorbs about 80%. So as the ice melts, there's more water exposed, more sunlight heats it up more, it makes the ice melt faster. That's an example of a feedback. And there are a lot of other feedbacks in the climate that sort of feedback on themselves and make things worse. And after a while, if any of these kick in, they can put out, for example, more CO2 or heat up the planet faster than we are. Once that happens, then it's out of our hands, and we're going to explore some of that as well. By the way, this is a chart showing this outer line was sort of the average from 1979 to 2000 of the summer Arctic ice. In 2005, it dropped a lot, and they thought, wow, that really dropped a lot. In 2006 was about the same. And then 2007, in 1 year, it lost as much ice equal to 3 times the size of California. That's a lot of ice. And this year, the last 2 years are tracking about at 2007. Slightly more than 2007, but they're not. But there's other problems too. The ice that remains is thinner ice than before. It's younger ice, and so that's why this is already, but most scientists think this is already a done deal, that this is going to be all gone. And the other problem with it all being, now this is ice floating in the water, so it doesn't raise sea level. It's like if you melt ice in a glass, and when the ice melts, the water level doesn't change. Ice on land, like in Greenland, if that melts, it flows into the ocean, that would raise sea level. We're going to talk about that as well. But even though it doesn't raise sea level, it will make the Earth a lot warmer because it'll be dark water instead of this mirror reflecting the sun away in the summertime. And the other thing it will do is speed the melt of permafrost, and we're going to get back to that. So this used to be the scariest graph I ever saw. I'm going to show you a scarier one later. But this is actually a graph from An Inconvenient Truth that shows CO2 concentrations in the atmosphere over the last 650,000 years. And it compares it to the temperature over the last 650,000 years. And you'll notice they track pretty well. And the reason, and it just shows that CO2 is a really good reflector of heat. It's only 0.04% of the atmosphere. It sounds like it's almost nothing. But it's actually really good at trapping heat. So it acts like a blanket. And that's really good, because without that, the world would be a frozen ice ball and we wouldn't be here. But it's sort of just right the way it was. And we're sort of doubling that blanket, and that's going to make it warmer. So what you're seeing here is this is where it was, and then in the last ice age, this is temperature, so it was about 5 degrees cooler, and the CO2 concentration was 100 parts per million less. Now you might ask, why does it go up and down every 100,000 years or so? Well, over a period of about 100,000 years, the Earth's orbit changes very slightly. It changes its shape a little bit, and the Earth tilts a little bit differently. The Earth wobbles around its axis every 20,000 years, and the orbit changes over a certain number of years. And then once in a while, it lines up just right, so the Earth is tilted a little bit more away from the sun while it's a little bit farther away from the sun. And that makes the temperature drop just a little bit because it's farther from the sun. That starts a bunch of feedbacks that reduces CO2 in the atmosphere, which makes it cooler, which reduces CO2 in the atmosphere, which makes it cooler, and you end up with an ice age. You end up with 2 miles of ice above New York City, when it was 100 parts per million less than it is today. So where are we now? Well, now we're 100 parts per million above where we were in the pre-industrial times. So again, when it was 100 parts per million less, there was 2 miles of ice above New York City, and now we're already 100 parts per million above, and where we're expected to be in my lifetime, actually, is much more than that, 600 parts per million, maybe more, by the end of the century. It's actually, this is IPCC level data, and it's actually worse than this so far. I mean, the emissions path we're on today. It's hard to imagine what this means, but there's another graph that actually folds this information into another form that we'll be able to see. But this is a model from the IPCC. Again, this is the old data, showing the Earth's temperature since about 1880. And you'll notice whenever there's a volcano, it cools the Earth off by putting smoke in the atmosphere and reflecting the sun away. And it drops a little bit. But over time, it's still going up, and that's because of global warming. And then starting in 2000, it's obviously not historical data anymore, it's predictions for the future. And there's different lines based on different emission scenarios. It turns out that so far, the actual emissions so far are worse than the worst case assumed by the IPCC. So I translated this into degrees Fahrenheit so you can see. So we're talking about the Arctic being 15 degrees Fahrenheit warmer than today. But we're going to, and you'll see these are degrees C over here. So the 5 degrees C, the actual emissions so far are worse than that line assumes. Now MIT, let's see if I think that's the next one. Let's move to the next one here. So MIT put out a study this January where they took all this data and they did a probability assessment of different temperatures at the end of this over this century.